Hello everyone, it's August 30th. Alright, it's late. Don't have much Ghana today, so let's just finish this one and call it. Alright, what do we have? Pacific Atlantic water flow. End by end rectangular island that borders both the Pacific and Atlantic. The Pacific touches the island's top and left, Atlantic touches the right and bottom. The island is partitioned into a grid of square cells. You're given an n by n integer matrix heights, where heights RC represents the height above sea level. Okay. The island receives a lot of rain, and the rainwater can flow to neighboring cells directly in north, south, east, and west if the neighboring cell's height is less than or equal to the current cell's height. Water can flow from any cell adjacent to an ocean into the ocean. Return a 2D list of grid coordinates result, where result I equals RC denotes that rainwater can flow from cell RC to both the Pacific and Atlantic Ocean. For example, this one cannot, but this one can, because it can flow here, and it can flow here, and it can flow. I see. And this one can, because this one can, because it's the highest. It's not high, but it can always flow. Okay, so what are we working with? So basically for each cell, we want to decide whether it can flow. So the question is whether one, so we have four, right? We have four adjacent. So the question is if any of the adjacent can flow into both oceans. Now we can go like, let's use this example, right? This one, we see we cannot go here, we cannot go here. So these two are no good, and then we can only flow to the Pacific. So there's no good, no good, no good, because you can say like for this one, can it go to both? And then we can basically use another table, right? It's basically just 1, 0, 0, 1, 1, 1, right? So this one is a 1. Let's say Pacific is a 1. And that's also, this one is a 1, right? And then for here, we say, okay, I can go 1, and I can go this, or I can go this. So to know this, I have to know this and this. So there's an order. I mean, maybe I need to record. How about recording the edges, because the edges has at least 1, right? Yeah, but this one is 1. This is 1, this is 1, this is 2, because we can go both, right? And these are all, no, actually 3. This is a 3. This is a, oh, there's actually also a 3. So yeah, if you can go, that's actually not a 3. That's just because this one cannot go. Like for this, how would you do this? I say for this one, I can go here, or I can go here. I can go here. I can go here. So it has to depend on this. This one we know already, right? So this one has to depend on this and depend on this. So now we have to go check this. And this is depending on this. How do we handle this circular dependence? I forgot. There was a way to handle this. Or maybe we say we only care about the Pacific in the first run. Okay? So we only care about the Pacific. So we have all this have Pacific. Right? The first row has Pacific. First column has Pacific. Right? And then we can consider this because they are all considered. Right? So we consider this. We say, can we go to Pacific? Yes, this can. Right? This can go to Pacific. And then this is done, so we can go here because this is done. Right? So Pacific, 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 Pacific. And this one cannot go, but this is Pacific. So maybe this will work. We just go in 2 rounds. The first round, we only look at the Pacific. Let's try 1, 2, 3, 4. 2, 3, 4. So yeah, so the first we just go all Pacific, right? This is guaranteed. Now we're looking at this. This cannot go, but we can go, so that's a 1. This can go, that's a 1. This can go, that's a 1. And this cannot go, but this is a 1. Okay, so this can go as a 1, 1, this one. So this one cannot go, so this is a 0. And this cannot go, so that's a 0, because Pacific is in this direction, right? So this can go, this cannot go, this can go, this can, ooh, can this go? This cannot go, this cannot go, this cannot go. 5, this cannot go. Okay, interesting. This cannot go, this cannot go, this cannot go, this cannot go. Okay, so that's Pacific, done. Now we look at Atlantic. And this side, right, which is or, right? Or 1, 0. So this one will be 3. This will be 3. This will be 2. Right? This will be 2. This will be 2. So this one will be 2. This one will be 2. This one will be 2. And this one will be 3. Okay, so now we go bottom to top. This one can go, so this one will be 2 because it can go ahead, right? And then we check this one. This one can go, so this will be 2. This one can go, right? So that becomes 3. And this one can go down, so down is a 3, so we all 3. Yes, that's still a 3. I think we got this. This one we can go, this will be a 2. This can go, so that, because it's a 2, so 1 or 2, that's a 3. This one cannot go, so it's remain the same. This one cannot go, so it remains the same. This one can go, yes, so that becomes 3. This one cannot go. This one cannot go. This one can go, but that's still 1. And this one cannot go. Yeah, we got this. Okay. I think that's exactly what we're looking looking for. Oh, shoot. Man, I haven't even eaten today. I'm very hungry. That's why I kind of don't want to spend too much time. Just get this done and then... what the heck? I got 31. So we need a DP. Alright, so we'll go mn heights 0. Alright, can we have heights 0? Yes, we can. Okay, dp equals 0 times n for this in range m. Okay. Now, so first round, check for Pacific. Okay, so what we're gonna do is just go through the first row and first column, right? So for I, j in range n, for j in range n, dp, dp is 0, j, or equal 1. For I in range m, dp, I 0, or equal 1. Then for I in range 1 to m, for j in range 1 to n, dpij, or equal what? Can we combine those? We have to, this is larger or equal to this, and, okay, so we can say or equals this or this, right? So this will be dp ij must be larger or equal to dp, let's say I minus 1 j, right? And dp I minus 1 j, right? And this one will be dp ij larger or equal to dp I, but j minus 1, and dp I j minus 1. So we go through the whole thing. Then we're gonna do the second round. Okay, so round 2, second round. Check for Atlantic. So this should be the last row. So minus 1. Let's do a minus 1. That's fine. So this one will be 2. All right, and then it should be the last column. So n minus 1. It's also 2. And then we go through bottom up, right? So for I shall be m minus 2, right? n minus 2 to 0, okay? For j shall be n minus 2 to 0. And then plus, right, down or right, plus and plus. Then return this, right, for I in range m, for j in range n, 3 rounds, ij, if dpij is equal to 3. All right. So we have this, this. I probably have to sort it in order to make it deterministic. All right. And this. Okay. Heights. Pacific, Atlantic. We can just sort it. Sorted. You know what? I don't like this. Rest.sort. Answer.sort. Then we run. Oh, the first one is not correct. What? We have 1, 4. Huh. That's interesting. Did you do something wrong? I don't think so. Well, a possibility is maybe we have to put parentheses here. I'm not sure, because these things, the order is always baffling. Okay, we put parentheses. See if that works. Nope, so it's not parentheses. Actually, parentheses make it even worse. All right, look at this. Huh? Is this not right? Ah, what the hell, man? Okay, this is... Ooh, what the hell? Huh. Wait. Let me experiment. This looks weird. Could be the Python side of thing. All right. So let's say a is 0. Okay. A or equal to this. Let's say 2 larger equal to 1 and 1. Actually, let's use a real example. That's fine. Right. So this should be true, should be 1 and 1, or 1 larger equal to 2, right? And 2. A is 1. That makes sense. How is this one not working, huh? Okay, let's print ij and print dpij dpi minus 1 j, right? And this thing. I'm not sure what I'm doing, but so we're going 1, 1. Okay, what's 1, 1? This is 1, 1. Right? Oh, DP. Oh my god. Oh my god. It's not DP. Lord. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 have some decency, man. A and DP, these are heights. Ah, crying out loud. Dude, what the hell, man? Seriously, what the hell? See, that's what happens when you're hungry. Your brain stops working. Alright, it's still not working, but I think this one at least will get a little bit correction. But how is it still not working? I got 1 4, got a 0 4, got a 4 0. Oh yeah, still not right. I thought by doing this we'll be getting back on track. And I don't see like why this like has to be, if it's false, it's gonna be 0, right? And if it's true, and then if this is 1, then we're gonna do 1. I don't get it. Print roll. Jesus. That's actually correct. That is correct. See, the problem is the second part. Okay, it's fine. Let's just inspect. That is good. So each one will look down, right? So m minus 2, m minus 1, m minus 2, right? J is minus 2 is this one. And if this is larger or equal to this, or this is larger or equal to, this is taking a long time. This is 0. Interesting. Very interesting. Why? Like seriously, why? Yeah. Let's print these out. Let's kind of get an idea what the heck are we dealing with. 0 and a 0. That's very interesting. This is larger equal to this. This is smaller. So this shall be 0, I understand. But how is this one also 0? Focus on this one. All right, 4 and 2. So larger equal to, if true, How about this? So this, so true and two. What? Wait, what? Oh, true is 0, 1. 2 is 1, 0. Oh my god. That is so stupid. Oh wow. We should use and, not bit end. Oh wow. That is so stupid of me. Oh wow. I should not use bit end. There we go. Now we're good. Yeah. Oh wow. I didn't know that. And on retrospect, it's quite straightforward, right? Ay ay ay. So confident, but so wrong. Do we have to do it more time? Huh. Maybe we do. What the heck? We're missing 2, 1. Interesting. I thought 2 rounds is good enough. Oh, come on. We're missing 0, 1, 2, 0, 2, 1. Let's draw it out. One, 2, 3, 8, 9, 4, 7, 6, 5. Okay. So first round, DP 1, 1, 1, 1. This one will get 1. This one will get 1. This one will get 0 because it doesn't flow. This one will get 1. That's first round. So I can actually check. Okay. Yep. Let's put a separation. Okay, so the second round, so will be 3, 3, 3, 2, and 3. Oh, I see. Okay. So how do you do it systematically? So we do this and we do this, which is totally fine because we only consider one ocean, right? And then we hit one ocean. And now when we hit the other ocean, So it's the second round. So the second round needs to handle a little bit more. So we'll do you know what? I think we don't need to do this. I think I will do this. Right? Holy crap. What do? We do this one. Oh man. Like if I is equal to 0, right? If I is equal to 0, easier. If I is equal to 0, because I can do the j minus 1, right? Oh, I can put them in one row. This could be I equal to 0, or yeah. So if I is 0, I can say this whole thing, right? You say I equal to 0, that'll be 1, or this thing. Right, which means if I is equal to 0, then that's just 1. Right, either this, or I is not equal to 0, then we get this value. And here is going to be j equal to 0, or this thing. But if j is equal to 0, then we won't execute this one. Now we will. The thing is, like I equal to 0, but j is not 0, so we will still execute this whole thing. And what if I and j both are 0? Hold on, this j is not, j is 0. Both are 0, yeah, then we don't do anything else. So, okay, and in this, we will say minus 1, right? Minus 1, and then we say I equal to m minus 1, or this thing. Right, if it's m minus 1, oh actually this is going to be slightly different, okay, so we want 2 and 2. Right, this is equal to this. If it's true, then we get 2, or this, or here, so this will be j equal to n minus 1, and 2. Or this thing. So we have this. I'll have another parentheses. Okay, let's try this. There you go. Now we can cover the other one. Oh my god. Alright, try this one. Huh. Yeah, it's not easy, man. Okay. Try it. Oh my god. Alright, so we have to really reconsider this. Really reconsider this. What the hell happened here? We're missing. We're missing 1, 1. Maybe we need to do 4 directions in the second pass. That's what I think. Let me think again. Yeah, because we can go down, then go left. Are you telling me that we do 4 passes? That's an interesting thought. So the first path, up and left. Second path, down and right. Okay, what's the third path? We can say the third path just goes through everything. 4 directions. Or we can do another path. Down and right. What have we done down and right? Let's see. It's 4 by 4. We can debug this. Okay, we have 1, 1, 1, 0, 0, 0, and 0. Okay, 3, 2, 2, 2, 2, 2, 3. right? Yeah, take a look. Yep. Wait, hold on. It's not. Oopsie doozy. That's a 1. Oh, that's a 1, that's a 1. So that's 3, 3, 3. And then this is not just a 2 because we need to look to the right. So that will be a 3. That will be a 3. Okay, we established these all 3. Now this is going to be a 3, yes. This is going to be a 3. This is going to be a 3. This is going to be a 3. This, okay. This, oh, this is going to be a 3. This is nothing. This is nothing. And this is nothing. This one, 1, 2. This can be a 3 because I can look left. So we shall just do this one more time. Right? We say third pass. And what do? We, because they already checked down. Hold on. So this path we check down and right, down and right, down and right. So the last path, so we already checked down and right. So, but if this one changes, and do I check all 4 directions? Maybe we check all 4 directions. Okay, we check all 4 directions. Just guessing this might work. And heights. Okay, that makes sense. But like if you want me to explain, let's say why, right? Why this is the case, I won't be able to. It's just it works. Like you have to check 3 times. Like why 3 times is enough? I'm actually not sure if 3 times is enough. 3 times is not enough. Are you sure? I see where this one is going. I have to keep checking until it stabilizes. Now it just doesn't stabilize. So we set the initial, and then we can say updates. Yeah, def update. Heights, dp, boolean value has changed, false. Then we go this, right? And then if temp if temp is equal to dpij, then has change equals true, and then we'll return has change. And then we say update until stabilized. So while true, self.update heights dp, and we say if has changed is true, if not, then we're gonna break like that. M is not defined. Of course M is not defined. Let's pass them in. Oh shoot. So we have infinite loop? How? Oh, not equal to. My god. Come on, man. This is getting ridiculous. I don't need to pass in because I can just do this. So I can save. Yeah. Dude, come on. Yeah. I mean, in this case, we probably can make this even simpler. We just update, right? Yeah, but it's fine. Alright, this shall be update until 200, I don't know. Come on. Give me some. Give me some. I passed, but with terrible. That's a terrible runtime. It's kind of just, you know, there's no way to go. That's the only solution we have. It was horrifying. It's the same. I bet this is the same idea. Ah, man. I mean, what we can do to check. If dpij is not equal to 3, to check dot append dpij ij. Okay. So after update dp and to check. Okay. So what we're gonna say for ij in to check. To check. We're gonna return a list of int. Alright, put this into check. Say blah 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 blah, and then we have a new to check. So next to check. Now we don't need this. Alright. And then if it's not the same, then next to check dot append ij. Because it changes, right? If after we go through all of them, then it doesn't change. Wait, hold on. We go through all 4. That should be at the beginning, man. Right? And then nij, blah blah blah. Right? And then I just update and then come out. If these two are not the same, then to check we add it, and then when I return next to check. Okay, so we say to check equal to this while to check. Something like that. Invalid syntax. Of course it's invalid. Take 3 position. Oh, dp, I need dp. Okay, so this is slightly faster. I think this will be faster. We check fewer things. Try it. Oh no. Huh. Let's see, how can we make this work? Yep, it ain't right. So what we're saying is, if go through the whole thing, right? And then if it doesn't change, then we don't check it. But apparently we still should. I see. If it's not equal to 3, we're going to push it in. And then we're going to say next to check. Right? And then we say this is going to be while true. If next to check is equal to check. Oh, I actually need to sort. That's fine. I'm going to sort here. To check dot sort. So now it's always sorted. So if these two are the same, right? Or not next to check, that we're gonna break. That's the thing. Okay. Okie dokie. Try the others. What the heck? What? Oh my god. I'm missing one. Oh, dp is not equal to 3. Oh, then I don't need this. Come on. Which one? Which one's giving me trouble? This one's giving me trouble. How? Oh, because I didn't do to check equals next to check. There we go. Yeah, I forgot. My bad. Alright. Fourth time. Just try to make it faster. Oh, this is ridiculous. This is ridiculous. What the heck? How about we do it 2 rounds? Man, this is getting out of hands. I'm sure the solution is not like this. Or we do it You know, like just here, whenever it changes, right? Whenever it changes. It's all we want. We know this one works, right? All we want is to make it slightly faster. And this is what we do. Next to check. And then we can just do while to check equals this. Oh, I didn't get the answer. Come on, I accidentally closed this. How do I get back? Oh, thank God, I got back. All right, I am back. All right, so pass, but we fail. You gotta be kidding me. What the hell? I already, this is, wait, it doesn't make any sense. Like, how is this different from the other one? I don't understand. Like, seriously, I don't understand. And this actually can be a set. Just need to add. Right, and then we just need to return a set of tuple int and int. Yeah, I don't understand. Oh. How? I just changed it to set. What the heck? I don't understand. So those initially are the ones, not 3, right? So I go through them again. Like, how is this any different? Doesn't make any sense, huh? So we check all of them, and we say if it's changed, then we put it in, because we want to check it again. And if it has not changed, like if we go all full, that's the thing. This we should always check. The goal is to have nothing change. Like if it has not changed in the current round, doesn't mean it won't change the next round. I think that's the thing. So, and then we just say change equals true. Turn has changed. I'll go back to the Boolean idea. Okay. And then we can just use a set. We can append. It's okay. So we're not really doing anything. So this will be right. Hopefully also make it a little bit faster. It's even slower. Alright, that's it. That's it. What's the good solution? I'm tired of this. I want it to end. I want to eat. DFS. Holy crap. Can do it with DFS. DFS. So what this says is we mark first and then we start traversing from every single one. Alright? We start this and we start traversing, going all directions, and then we say the next one. To go. Yeah, like if I can go, then definitely I should go. I go 4 directions to go. If next one, go to the next cell only if it has not been visited from the perspective of the current ocean. If it's not being visited, then we visit. If it has been visited, then we don't go. Interesting idea. So it means the original traversal we will hit, right? Actually, this one will be easier. So we go here and then we start to go. Basically, we're trying to find all the things we can find with the current ocean, right? We traverse everything for the current ocean, and then we traverse this for the current ocean, and that's it. That's the 2 rounds. How many are reachable and how many are reachable? So oh hell, this is good. Oh my, this is good. So basically we want to find how many are reachable from the Pacific, how many are reachable from Atlantic, right? And then we just traverse to find like if it's reachable. Right? And then we just keep adding the reachable. If this, the next one's not unreachable, and this is this, then that means it's reachable. Oh, yeah, this is very bad. Basically, traverse the heights as many times as possible, right? Until it stabilizes. Terrible idea, but works. Yeah, I'm gonna record this. 8%. Terrible. All right, let's do the right thing. Correct solution. We use DFS to find all the cells that can reach Pacific and all the cells that can reach Atlantic. Right? Then find their intersection. Now it works. Now this works, right? This works because we have deterministic starts. We know the first row and first column must reach Pacific. Is it Pacific? Yeah. So they serve as the starting point for DFS to find all the cells that can reach the Pacific. The same goes for the Atlantic. So we have this, and there's no DP actually, right? And then we say P reachable, Q A reachable, set and set, def DFS I J reachable. It's going to be a set of tuple int and int, and no, I don't have to return anything. Can we just say alright, this is what we say. For this and this, if this and this, and heights, actually we're gonna say ni nj, right? Means b larger than ij, right? And ni nj not unreachable because we don't want to go backwards. So that's the case. Now say reachable dot add nij. Right, and then DFS nij reachable, and then we just finish it. Go to the next one. Yeah. Then we can just say for I in range M, right? Then we go DFS I, first column, that's P reachable, right? And DFS I, last column, that's A reachable. The same thing for J in range N. First row is P reachable. Last row is A reachable. Once we're done, return list P reachable dot intersection A reachable. I think that shall be it. Huh. Oh, missing. I'm missing something. Oh, we forgot this one should be in front. Still not right. Oh. I think we'll pass, but here it's not because it's a tuple. Oh, we'll try. I think it will pass. Oh, they ask for a list. We're not giving them a list. Yeah, this will pass. Yeah. Holy crap. Hmm. Yep. Alright, that's it. Wow, it was a terrible day. Struggle. I'll see you guys tomorrow. Adios.